As one bear already has a number on its back, Steve knows it's been tagged and studied. Using a tranquilizer dart, he sedates the unmarked bear, a female.
What we're trying to do is to understand the welfare of the population and to look into the future to see what the future welfare of this population is likely to be.
Steve and his team have an hour to do a number of tests to assess the size, weight and health of the female before the sedation wears off.
Well, this is just to get different measurements, and this is a total girth. So it looks like 120.3. Yep.
The research has revealed that many polar bears are becoming malnourished.
Polar bears depend entirely for their nutrition on seals that they catch from the surface of this ice, and therefore they're entirely dependent on the sea ice for their survival. And our big concern right now is the sea ice in this part of the world has been declining at a rapid rate.
Steve has made a revealing discovery. This bear is producing milk, but her cubs are nowhere to be seen.
So what's happened is she's lost her cubs a while ago, and now she's in heat again. And so that means that she came out of a den someplace along the coast this spring, lost her cubs.
In recent years, Steve has seen a big fall in the number of cubs surviving their first year. And he blames the changes in sea ice. Because there's less of it and it's thinner, the ice forms more pressure ridges. Walls of jumbled ice which present formidable barriers.
If you're a tiny little cub, only about this big, it's pretty hard to negotiate those sorts of things. You're more vulnerable to being prey of another bear or getting injured or not being able to keep up with your mother when she's coming out of the den to try and find food.
Steve's findings have helped lead to the US government classifying polar bears as a threatened species.
445.
Our forecast suggests that polar bears could be gone from this region where we're standing right now within the next 50 years. I've been coming up here for 28 years, and I've always been able to count on finding polar bears. If I were to live to the day where I couldn't come up here and see polar bears, that would be pretty hard for me to take.
In spite of the way she looks, the bear, once fully awake, will make a complete recovery. The sea ice has declined because, while temperatures in the rest of the world have risen by nearly 1 degree, here they've risen by nearly 3 degrees.
We see a bigger response, more warming in the Arctic because of feedbacks, which are amplifying factors. Specifically, it's the albedo of the Earth's surface, which is the reflectivity. The amount of the sunlight that hits the surface and is reflected is larger if you have a white surface covered by snow or ice. So if that melts back, that exposes a darker surface which absorbs more sunlight, and that increases the warming and melts more ice. So you get a bigger change in the Arctic than on the global average.
The impact of rising temperatures in the Arctic is not only felt by the animals. Locked in by sea ice 9 months a year, Barter Island is home to around 300 people, mostly Inupiat. For countless generations, life here has revolved around hunting animals for survival. Robert Thompson is a local Inupiat hunter. Today he's heading out to what was once a bountiful hunting ground.
we're losing some of our mammals. We're going to be losing muskox. They'll probably be extinct in this area in my lifetime. The polar bear are going to be gone. The caribou are diminished, and some of the bird life. If we don't have our animals, we're gone. We're done as a people. Our culture is based on the animals. We might import different types of food and still live here, but the things that we do that define us are going to be gone.
By the middle of this century, most climate scientists believe we will be living in a 2-degree warmer world. The only way to avoid this is to curb our emissions and change the way we produce energy. Over a quarter of the greenhouse gases we produce come from fossil fuels burned to generate electricity. Coal, oil and natural gas power almost every aspect of our lives, and we show few signs of cutting back.
We will get global warming of at least 2 degrees Celsius if we continue even a small number of additional years at the rates we are changing now, because the expanding economies in the developing world are growing so rapidly and their CO2 emissions are growing so rapidly.
The fastest growth has been in China. It's recently overtaken the US as the world's biggest emitter of greenhouse gases. China builds 2 large coal-fired power stations every month. Coal powers much of the world's economic development and a staggering 41% of worldwide electricity generation. But now there's a remarkable technology that allows us to use coal without releasing CO2 emissions into the atmosphere, and it's already in use. This $2 billion power plant in Beulah, North Dakota, provides energy for 500,000 homes. Its fuel source is a local coal, and its pioneering technology is called Carbon Capture and Storage, CCS. CCS is a 2-part process. The first part captures carbon dioxide at its source.
So inside this pipe is pure CO2. Prior to the year 2000, instead of putting it into this pipe, we were venting it into the air from that stack over there.
Floyd Robb works for the power company.
Any carbonated beverage has CO2 injected into it. And this bottle's been sitting in the sun, so it's warm. And when you shake it up, it's under pressure. When I release that pressure, the CO2 flashes off. It's a very similar process that we use here at the gasification plant, only we use chilled methanol.
Methanol is a chemical compound which, at around minus 70 degrees Celsius, is very efficient at absorbing carbon dioxide. But when the methanol is warmed and depressurized, like the bottle of soda, it releases the CO2. It's then captured and compressed. But this is only the first stage of CCS. The real challenge is where to store the enormous quantities of carbon dioxide that plants like this will capture. The solution could be found here, in the magnificent sandstone canyons of Utah's appropriately named Carbon County. Brian McPherson, a geophysicist at the University of Utah, is heading up an $88 million government research project aimed at finding a way to safely store carbon dioxide. The most promising solution? Injecting it into sandstone.
Sandstone is a terrific storage medium because even though it looks solid, it's actually very porous. There's lots of pore space. In fact, 10 to 15% of the rock matrix itself is actually pore space that usually holds water or brine, and we're looking at injecting CO2, replacing that water or brine with CO2.
Brian's team plan to inject 1 million tons of CO2, the annual output of a small power plant, into rock formations several kilometres underground. In this canyon, those layers can be clearly seen.
The Navajo Formation, it's a massive sandstone layer. You can see it here as a sheer cliff face right behind me. Below the Navajo is the Kayenta Formation, a dark banded layer, and below the Kayenta is the Wingate Formation. The Wingate is our storage target at our test site. High porosity, high permeability, whereas the Kayenta above it is low porosity and low permeability. And the idea is that the Kayenta will prevent the CO2 from migrating towards the surface.
If their natural seals hold, the potential storage capacity of geological formations like sandstone is huge.
In the state of Utah, where we are now, we have at least 50 years of potential storage in geological formations, and that's a conservative estimate.
CCS could offer us the maximum benefit with minimum disruption.
The merits of CCS are that it allows us to use the largest source of fossil fuel energy that we have. So many countries are already using coal. We've got to figure out some way to use coal without the damaging emissions. So we have to try that, and then that may give us time as we're developing cleaner energies on the long run.
But there's another hurdle. At current cost, CCS could add as much as 60% to utility bills, and government studies won't be finished for up to 10 years. Only after 2020 will large-scale CCS adaptation be considered, and that may be too late. If we don't stop the increase in overall global emissions by 2015, most experts agree a 2-degree warmer planet is inevitable, and that could make our climate even more unstable. One of the most significant consequences of climate change has been the increase in sea levels. They've risen more than 20 centimetres since the mid-19th century. In a 2-degree warmer world, they could be over 20 centimetres higher.
Water, like many other substances, expands when you heat it. And the fact that the surface layer of the ocean is warmer than it used to be means it's bigger than it used to be. And the only place the water can go is up. So sea level rises for that reason. The other reason sea level rises is when you melt ice that was sitting on the land and it flows into the ocean.
The warming and expanding oceans will have another consequence: extreme and destructive weather, which will become much more common. 2008 brought devastating hurricanes like Gustav and Ike. It's estimated that more than 100,000 people died in Burma as a result of Cyclone Nargis. No one can link these events directly to climate change, but many scientists believe that higher temperatures already are contributing to storm intensity.
Latent heat provides the fuel for storms. Thunderstorms, tornadoes, tropical storms, hurricanes. The energy comes from latent heat. So warmer ocean waters provide more fuel for the storm. So we expect the strongest storms will become stronger.
The destructive impact of this will be felt in unexpected places. New York, 8 million people. One of the biggest and richest cities in the world. New Yorkers like to think they've seen it all, but in a warmer future, they'll have to deal with the threat of regular and devastating floods.